Hey folks, so in this video I'm gonna go over how to make a little audio visualizer with GetSpectrumDataHelper from scratch. So let's get started. So I've made a tutorial folder, so that's where I'm gonna put my new scene. So I'm gonna create scene and I'll call this tutorial on my end. Obviously you can call it whatever you want. I'm gonna delete the directional light. I'm gonna switch my main camera background to color instead of sky, and I'll do like a deep blue. That's just the look I'm gonna go for with this. And then, so the next step, I've got my GetSpectrumDataHelper package here. So I'm gonna grab the script. So first I'll start off making an empty game object, and I'll call it GSTH for short, GetSpectrumDataHelper. I'm gonna drag the script onto it. Then I'm gonna grab some audio. So in this case, I'll start with the test sounds. So I'll just drag this here. It'll create a game object automatically. I'm gonna rename the game object to be audio source. Then I'm gonna set my GetSpectrumDataHelper script to be audio source. And then I'll drag the audio source in. Cool, and that's my setup. I'm not gonna touch anything else. So let's actually turn on the debug graph and just make sure that that's all working. I'll hit play. I'm gonna pause. I'm gonna move the game window down here. Oh, I've got my gizmo view turned off, so I'm gonna turn that back on, and now I'll see my graph. It's in 3D space right now. I'm gonna switch to a 2D view, and I'm gonna unpause it. Okay, I've got my frequency outputs here in green. I've got my overall decibel level in red. And that's looking good. Okay, so now I'll move on to making my own script. So for this example, I'm going to make a script that instantiates a prefab, creates a bunch of instances of a prefab in a row, and then each instance of that prefab will scale according to a different frequency from the GetSpectrumDataHelper output. So I'm just going to do it all in this tutorial folder. I'm going to say create a C# script. I'm going to name it, well, in my case, tutorial. You can omit that part, but prefab audio visualizer. Okay, I'll double click it. Cool. Then what I'm gonna do, I have where is it? I have a setup already. I think this is my example setup here. So I'm just gonna copy and paste this just for myself, just so I can refer back to it. And I'm just gonna comment it out. I'm gonna write it from the beginning. Okay, so the first thing is gonna be, we'll want a public game object, and we'll name that, we'll just name it prefab. That'll be the prefab that gets instantiated, and we'll set that in the inspector. Then we'll want an array of game objects, and we'll think declare is the right word. Declare that like this. And I'll call it prefabs. So all the instances we create will be stored in this array. So let's start with that. And then we'll need our GetSpectrumDataHelper. So I'm gonna say public GetSpectrumDataHelper. That's the type. That's the script. I'll call it GSTH. And let's start by building that. Okay, so I'm going to create an empty game object, call it audio visualizer, and we'll drag our script onto it. Okay, cool. And now we can connect our GetSpectrumDataHelper into our inspector slot here. Cool. And then we'll need a prefab. We can go ahead and make that real quick too. Let's just make a cube. I'm going to reset its position. I'm going to remove the box collider because we don't really need that. We'll keep that material for now, and we'll call this our audio cube. And I'll just drag that into my tutorials folder. That creates a prefab. I can delete the instance of it in the scene. And now I can go to my audio visualizer and connect my prefab. Okay, so far so good. So next step, let's go ahead and create the instances. So we'll do that in the start method. So we'll say for, we're going to do it in a for loop, for int I equals 0. And actually, before we even do that, we're going to want to set the size of the array of prefabs. Okay, so prefabs equals, it'll be a new game object array. And the size is going to be 128, but let's do it this way just to, well, yeah, let's just do it. Just say 120. We'll just do it that way. Let's see what I do wrong here. Let's just delete this for a second. Oh, I deleted one of these curly brackets. There we go. Okay, so that sets the array size. Now we can loop through, for loop through this array. So for int I equals 0, I is less than 128, I plus plus. We could also do it, I is less than prefabs dot length. That's another way. Okay, and then we'll say, so we're going to instantiate our prefabs. So we'll say prefabs at the index I is going to equal a new instance, and we'll do it this way. Instantiate a game object of type prefab. This is from this guy up here. Okay, that's going to create them. Then we need to say where are they in space. So we should be able to do prefabs I equals, oh sorry, the transform, the position is going to be equal to the position of this game object. So we want it to be where instantiated wherever this game object is, plus an offset. So we'll say, whoops, not equals, plus new vector 3, and we'll offset it in x. So offset by I, and y and z don't have an offset. So that'll create a row of them. Let's go ahead and run that and have a look. pause. Cool, so here's our 128 audio cubes. Here they are in a row. You can see if we just arrow down our hierarchy, we can see them all. Okay, so that's good, but as you saw, they're all directly in the scene, kind of crowding our, not only crowding our, hierarchy view, but also not grouped under anything, so it'd be hard to move them around. So this next step will be to take care of that. So we're going to parent them to the game objects transform. So transform dot parent for that is going to be equal this game objects transform. Okay, I'm going to build that. And then let's test that once more. Cool. So here they are again, but now they're all parented to our audio visualizer game object. And if we rotate that game object around, they follow along with it, no matter where it is in space. And so we like that. So let's reset our audio visualizer's position to 0, and move to the next part. So the next part is going to be about updating their scale. So this will be a similar approach here. We'll say for int I equals 0, like above, I is less than prefabs. We're going to say less than 128 explicitly because we only have 120. We have 128 prefabs, but that's because we have 128 values coming from GetSpectrumDataHelper, and we want that to be fixed. I++. Okay, and we'll say prefabs I dot transform dot local scale is going to be equal to we're going to say vector3 dot 1, so its scale will be equal to 1 all around. Say times vector3 dot up. All right, not times. We want to do plus. That's what we want. So vector3 dot up is 0, 1, 0. So it's basically 1 in the y, which is up. So we'll add scale to the y-axis, which will make our cube scale up and down. And that vector3 dot up, put in parentheses, will be affected. Its magnitude is what will be driven by our GetSpectrumDataHelper. So here comes the fun part. Now we can call GetSpectrumDataHelper, and we want the musical decibels at index I. And now our cubes should scale to the music. Let's do one more thing though. Let's create a scale multiplier so we have some control. One extra level of control, and we'll say times scale multiplier. Okay. And let's run that. Cool, and that's working. Let's do a fun sound like this one. Cool. So that's that might be enough to get you started. You might stop the video here and go start doing your own thing. But if you want to keep following along, I'm going to do set up a shader that will glow based on scale as well, and then also go over the overall decibel parameter you can grab as well. And so let's do the overall. We won't have it do anything in this video, but I'll just show how to get it. I'll do debug.log so we can see it, gsth.overall decibel level, and that'll give us the overall decibel level, and you could have that drive something too, maybe. So if we hit play, that's this red line here, and it's basically the it's the average of all, of the volume. It's not calculated like your regular average. The calculation's a little more complex, but there it is. So, and it's in this 20 to 30 range, looks right. It is relative to, your multiplier and your reference values. So just like your multiplier will increase your output, it'll also increase the overall decibel value output as well. There it is. Now it's in the hundreds. So that was just to show that. Okay, let's move on to the shader. I'll comment this out. Cool. So that's it for our script. So now let's create a shader for our audio cube prefab. There's our audio cube. So I'm going to say create. I'm in the HDRP, and this asset's kind of designed. The example scenes are designed to work with it. If you're using it in another render pipeline, then obviously you'd create your shader graph, appropriately for that pipeline, but you could probably still follow along for most of this. Anyways, I'm going to go to HDRP and I'll do a lit graph. Yeah. And I'll say audio glow, call it that. Actually, I'll call it scale glow because that's more appropriate to what it is. It's going to be driven by the scale of the cubes, which indirectly will be the audio, but directly it will be the scale. So let's open that. And what we'll do for this is we're going to right click, create node, then we're going to search for object, I believe, yeah. And this node will return the scale of whatever object the shader is attached to. So that's a nice way to keep the same shader on different things, but have it respond differently for each object. So the scale, we'll want the scale, and we'll want the magnitude of the scale. So to get that, we'll actually do distance. So the distance from 0, 0, 0 to whatever number our scale is, that's going to be the magnitude. Cool. And then let's create a emissive color. Let's default that to something super obvious like pink for our test. And then we'll also want, and let's do a vector 1. That'll be our emissive multiplier, so we can dial it. I already know from doing this that it's gonna, for it to be visible, it's gonna have to be this kind of high number. So I'm gonna multiply that, our emissive multiplier, by 100, and that'll make the slider not have to go quite as high when we're dialing it in. Okay, so we're gonna multiply, lots of multiplies. Multiply those two together. So this setup will basically be our, what scales the emissive color, how intense it is. So we'll multiply that by our emissive color and connect that to emission. Okay, I'm going to save this, and I'm going to create a new material. material, and we'll call that our audio cue material. We'll assign it to the audio cube prefab. And our material, we need to make sure we actually set it to be our scale glove. Okay, so far so good. Now let's hop back into our scene. Let's turn off our debug graph. We've got our audio visualizer all set up. We did our background color. Let's also do let's create an empty game object. This will be our post-process settings, controls. We're gonna add search volume. We're gonna add a post-process volume for HDRP. We'll create a new one. It's gonna put it somewhere. Oh, okay, just put it in tutorial under a tutorial folder. That's fine. I'll call this tutorial post-process. Okay, so that's just a profile where the settings will be saved. And then I'm gonna add an exposure override. I'll just start with that. And I'll say mode, use physical camera. That way it'll be my camera's ISO and shutter speed that drive exposure. And I'll just set those to 100, kind of semi-similar to real-world values. I'll hit save, and let's hit play. I think our camera won't be in the right spot initially. Yeah, so everything's looking good, just our camera needs to be more like around here. But when I stop hitting play, the camera is going to snap back. So what I'm going to do is copy the transform component. Then I'll unpause this, go back to my camera, and right-click paste component values. And that'll put the camera where I wanted it, where I had it during play. Let's hit play again. Cool. So we've got things working. Now we can go back to our material. We've got our emissive multiplier. Let's set it to like 10. Very nice. So let's, for one final, to just spruce this up a little bit, let's add let's just milk some of these post-process settings. Why not? They're cheap and easy. Let's do some film grain, thin, let's go kind of heavy-handed. Then we'll do bloom and maybe lens distortion for fun. So bloom. Okay, let's crank up the intensity. The scatter gives you different looks. I kind of like this like big scatter that makes it look like it's like there's like fog or something and the light's diffusing into the fog. And then I'll crank this multiplier a little harder, and we can change our color to whatever we want. Maybe that scatter is a little much. Cool. And then let's do a song. Okay, and let's just test out. We should be able to rotate our visualizer there, so we could do something kind of fancy like that. And oh yeah, one other one I wanted to add was the chromatic aberration, because why not? And then we could play with this lens distortion. You can get some kind of cool effects like that.
Check it out.
Cool, and if you've made it this far, this is now the fun part, and you can just plug in all kinds of sounds and just see what they look like a modem. Alright, hope this video was helpful. Thanks for checking it out. Thanks for buying the asset, and have fun.